So, hello everyone. I'm Jeremy. I work for Guerrand, the company behind Calico. And today I'm going to do a quick demo, like half an hour, on the product we have called Calico Cloud, which is a commercial offering of Calico open source. So I'm just going to log into the console, and I'll show you a quick tour of the product, and then we'll do a few exercises, such as securing a microservice application. So let's start. So you can try Calico Cloud yourself and sign up for the product. You'll have 14 days of trial. So you can connect any cluster from like GKE, EKS, AKS, and so on. So for this demo, I have created a cluster in Azure as AKS. I'm using Azure CNI. I could have used Calico CNI as well, just to show you that we are compatible with most of the CNIs and cloud platform, but also Rancher, OpenShift for people who prefer to go on-prem. And we also have Calico Enterprise, which is the same version as Calico Cloud, but it's on-prem. So some people, they have different needs, and we can answer those with those two products. So when you connect into Calico Cloud, is it big enough for you at the back? Or a little bit more, maybe? Better? So when you connect to Calico Cloud, the first thing you have to do is just to connect your cluster. So I'm going to expand this menu here. Like this, you'll be able to read. So we have managed clusters. And here you can connect as many clusters as you want. So it means you'll have one pane of glass for all of your clusters. They could be, pre-production, production, AKS, EKS. Everything can be merged, basically, in this view. And we have here two clusters, Tigera Labs and my AKS cluster, and it's connected. So now from this page, what we can do, we have multiple views, which is the dashboard. So I'll do a quick tour, like maybe 10 minutes, and then we'll go on the exercise. So the dashboard is very straightforward. It's just a pane of glass with multiple widgets. So you can see, the policies you have in place. You can see what data is getting allowed or denied by those policies. So if something is getting denied, it's going to be red here in the middle, and then you'll be able to know exactly what's going on. So you'll be able to identify the pods, the traffic, that is getting denied. And you can also see your endpoints, if they are labeled, unlabeled, etc., and some processes. So it's a very quick page with few widgets. I'll go to policies, because it's probably where you're looking for the product. Calico is a CNI, but it's also a policy engine. And here in this view, we have all the policies that you have put in place in your clusters. And the difference with Kubernetes is we don't have only one tier, which is the default. We have created a set of tiers. The idea of the tiers is you can link them to users with RBAC roles and permissions. So it means you can have your developers creating policies in a product tier. So they are able, to create a zero trust approach or microsegmentation for the application, but they'll never be able to create a policy in the security tier, where maybe your security team will be in charge of maybe PCI compliances or in and out, egress or north-south control. So the idea is you give a bit more responsibilities and way to deal with the policies to different teams, so it avoids some frictions between teams. You don't have to create a ticket for a change. You don't have to get it reviewed. The developer will be able to fix his policy in his application without asking someone else. So it's going to make it much more easy and fast for your teams. And in this policies board, you can see multiple policies. So later during the call, during the talk, we're going to create policies. But quickly, you can just click on them, and you're going to open the manifest. So instead of having a YAML, we're going to have this kind of a firewall policy-like page. And you'll see the name, the order, the namespace, and all the labels, and so on, like egress, ingress, rules, etc. So we'll go in detail a little bit later. And from here, you can also create your policies. So you can still use your pipeline, like CI/CD. You just apply your manifests, or you can create them from scratch here. And we also have multiple added features for the policies, like we can stage them. The idea of staging is just to create a simulation of what would happen if the policy was created. It's not going to block the traffic. It's going to just see what's going on. So it's perfect if you're in production and you have to do a policy and you don't want to break your application. So that's the staging. We also have recommend a policy. So there is a recommendation engine. So what's happening here is you can put in place an application, like it was developed by someone else, and you're just a platform engineer, you put it in place. You don't really know the application. So you just put it in the environment, you let it run maybe for a day or something, and when you click on recommend a policy, it's going to see all the flows between those pods, and it's going to create policies to allow only them and block the rest. So like this, you have this kind of zero trust between your pods. Of course, it's a recommendation, it's made by the machine, so as a human, you have to look at the recommendation and maybe add or tweak some rules, because imagine you have like a backup during the night, it may be not seen in the recommendation. Okay, so let's go to maybe endpoints. It's very quick. Basically, you've got your inventory with all your pods. And if you're looking for an IP, maybe a label, a namespace or something, you can simply expand it, and you'll get all the data. You don't have to open command line, basically, to get all those informations. So if you want to see if the pod has a policy, you can just see here. And there's a security, deny thread feed, and you can click on it, and it opens the policies. Network set, that's something very interesting as well. Maybe you have a list of IP addresses where a pod shouldn't talk or should talk to, and instead of having to put all the IPs manually in the policy, you can just create them in a network set and use the network set inside the policy. And what is even more powerful is you can use thread feed. So imagine you have a security third-party vendor that provides a URL or a text file with multiple IPs, with like the daily malicious IP addresses. You can just put the thread feed here. We can edit it, see, it's just an IP block. It's a text file. We can just copy it. It's from Feodo Tracker. And then here we can see, so Feodo, it's a Swiss company. Every day they're going to refresh the list of malicious IP. So we can use the thread feed to feed a network set, and the network set will be used in a policy. So it means your pods that need a connection to internet, they will never be able to talk to malicious IP addresses. So it's how it can help you. We can switch to the service graph. Service graph is also a very nice feature because in the cluster, everything is abstract, it's virtual. You will have maybe hundreds of pods, and you don't even know which one is talking to which one because the microservices, it's kind of a maze. Everything is all over the place. So the service graph will automatically generate a map of the cluster. And at the moment, it's based on the namespaces. So you can see few applications, maybe Java app, storefront, kube system. And you can see the relation between the namespaces. So if a namespace is talking to another one, like storefront to kube system, or to a public network. And if I click into the namespace, at the bottom, we see the flow logs. It's going to be automatically sorted. So you'll be able to see all the flows with all the metadata from source and destination. So the Wi-Fi, is it going to show me the flow logs? Yeah, okay, that's the Wi-Fi. And see, I clicked on the Acme namespace, and I'll get all of the metadata. So I can just click on the flow log. I can see source destination for the IP, the name, namespace. It could be also the labels. So it's perfect for you to understand how the namespaces are alive, how they live their life, talking to each other, what should be allowed, what should be denied, what is suspicious. And you don't really need to be like a pure Kubernetes platform engineer to understand what's going on. If you're in your transition phase and you're still kind of weak on the skills, people can clearly use that to speed up, to get up to speed in terms of competency. At the moment when you start Kubernetes, it's all in command line and it can be a bit stressful. You don't really know where to start. So that's a perfect tool to understand how it works. I can double click into a namespace and it's going to break down the namespace into pods. If it wants to do it, of course, it's a demo. Come on, storefront. And I just tried like 15 minutes ago. It was working. Perfect, it's there. So here we have the microservices that are living inside this namespace called storefront. And in a few seconds, you can see the correlation between the microservices. We can understand the way this application was built. There is a front end here. And this front end is talking to two microservices, 1 and 2. And then the microservices 1 and 2 are talking to the backend. So there is this kind of, DMZ zone-based architecture, but it's kind of abstract in Kubernetes because all the network is flat. So that's why with the policies today, we're going to build this kind of virtual zone-based architecture to ensure that front-end will never talk to backend and vice versa. And if you click into microservice 2, you can see the flow logs, etc. So let me check the time, 22 minutes. OK, perfect. Just going to see. So on top of the service graph, we can also click on a singular connection. And you can also get on the right panel a quick overview of what is this communication. It's like TCP, AT-AT. And you can see the egress, ingress, and the policies. So if your flow is going through multiple policies, you can see the list of policies. If you have some network connectivity issues, we can also simply right-click into a service and just initiate a packet capture. So it's super convenient when you want to get a pickup file and use it into Wireshark. So we can go into the demo right now. So I have here on the side my AKS cluster, very standard cluster, and I've got my storefront application somewhere here. There it is. And we can see we have like five pods. So the idea now is I want to ensure that my pods can talk to each other in the right way, and we're going to block everything else because it's the zero trust approach. You don't trust all the other flows because they are not part of the application. So if there is an intruder later, it will be blocked. And we also want to create this micro-segmentation where this namespace cannot talk to other namespace. So I have a set of policies here. So I've got a product restricted, a trusted. So let's do it. kubectl apply -f, and we're going to do this one. I forgot the YAML. Is it? Yeah. So they are YAML file, but I download them from GitHub. It didn't get the name. It's right. So you can imagine right now you have your CI/CD pipe and you're just going to push your policies. You don't have to use the CLI, the UI if you don't have to. So trusted, and where is my DMZ? this one, product, kubectl apply -f DMZ. Okay, so I have applied 3 policies, and if we go in the policies board, we're going to see them in the product tier. That's my tier for my applications. It's where my developers can create policies without asking their colleagues. And then we'll see in a few seconds, yeah, it's getting refreshed. We're going to have some endpoints affected to them. So the DMZ policy, it's going to match the labels firewall zone DMZ. So what I've created here for my storefront application, we've seen earlier, we have the front end, microservice, and the back end. So we can virtually recreate a zone-based architecture like we would do for servers, with the different switches and VLAN. You can create the front end, back end, and so on. In Kubernetes, everything is flat. Everybody can talk to everybody, which is a security concern. So you can mimic that zone-based architecture with policies. So I'm going to ensure that the front end will never talk to the back end because it doesn't have to. So why would you let the door open, basically? It's a security breach. And now, here is the problem with my policies. We can see they are denying packets. And what I can do now, I can go in the service graph, and I can start to refresh it, maybe 2 minutes. It's been, 2 minutes we're talking? And we start to see some red. So it means if you see some red after an action, a human action, you maybe have a misconfiguration somewhere. If it's during a normal production day, maybe there's something suspicious. So you can click here, and we can click here and see it's UDP port 53. So basically, kube system, it's where there is the kube DNS. I blocked kube DNS, so the pods cannot talk to each other. So if I go in storefront, it's probably all broken now. Yeah. So I'm going to add my policy that is called platform allow DNS. So this one, I'll put the policy into a platform tier because it's a global policy, kind of. This one was a storefront, a namespace specific, and this one is a global. You can create policies for the whole cluster. And why in the platform tier? It's because all my pods need the kube DNS. So instead of creating a policy per application for kube DNS, I can just make it bigger, and it's done once, and that's it. I don't care anymore. We just need to wait a few seconds, for the endpoints count, and it should be something like 44, like this one, yeah. And now, after a few seconds, the application should be back and running. Yeah, 46. And we can see the traffic allowed, it's 500 bytes, and so on. Very straightforward. But here, there is a little issue. My policies are authorizing data, but now we need to put a default deny to close the application. Otherwise, there will be no zero trust. Because if right now I take a pod in storefront and I ping another pod, it's going to work. So that's why the Kubernetes best practice is to always put a default deny. So here we should have a default deny somewhere. This one. I'm going to recall the command. And it's called the default deny. So the policy is created, and here it is, default deny storefront. So now what's happening is my pods, they are all secured. They can only talk to each other or the resource that is needed. And if I put an intruder, which I will just after, we'll see that the default deny will start to get some packets. So there is also something else we can see in the policies. It's something that is very important too. At the bottom, or even here, we can see the whole metric or statistics about what is allowed and denied. But if I scroll down, I can also have the statistic per rules. So if you have a policy with multiple rules, you can see exactly which one is denying the traffic. So it gives you a much more visibility on your policies and what they are doing. It avoids you to read the manifest to know what pod is doing what in theory, and then accessing the shell and starting to troubleshoot. In a few seconds, you'll get your informations. Also, we have the changelog. So maybe you are in a, I don't know, banking, banking business, and you need compliances, and you need to track who's doing what. Basically, everything is here. So you can see your name, and you can see which user has done what. Also, you can go in activity here, and in timeline, you'll have the whole cluster modifications. So it's perfect for security as well, because you can see what was done, policy created, deleted, if it was a stage 1, etc. So now we can start proving that the default deny and my zone-based architecture is working. So I'm going into my workshop. And here we have the attackers. Okay, it's here. It's an intruder pod. So basically, it's just a pod that is going to ping everything in my cluster. So now, I'm going to deploy this pod in the storefront namespace. So let's wait a little bit for it to get deployed. What's happening here? Doesn't want. Okay, that's awesome. It's created random. Actually, we can see it. Where is my attacker? It should be here. Yeah, here we go. Takes a while. So now we have this ping box in storefront, and if I go in my policy, it's going to be read everywhere. And also in the service graph, we'll start to see some red traffic coming to everything. So let's have a look. Let's change into 2 minutes. It's going to take a little while. So in the meantime, while the flows are getting populated, we can also talk about managed clusters. So earlier I said you can put multiple clusters. If you want to see another cluster, like Tigera Labs, you see in the policies here, we can just switch from one cluster to another one. So if you have like 20 clusters, it just takes a second. And then we're going to see the policies that are on this cluster. So if you have like a test environment and a production, you can compare if you're kind of compliant visually, and you can see if your configuration is all right. Very straightforward to change clusters. Okay. I suppose now we'll have the attackers logs and flow logs. Okay, that's. Yeah, maybe I should have used the speaker Wi-Fi instead of the public Wi-Fi. That's probably a mistake. Okay. So here we go. We just need a bit of patience, but we're here. So now we can see that the attacker is trying to ping every single namespaces, every single pods, and everything is blocked out of the box. So if someone was able to hack one of my pod and deploy another pod, it's blocked because I applied the best practice, which is zero trust, default deny. And that's it. We have created the micro-segmentations, and this namespace is working completely fine. And if there is a breach, it's not going to affect. So without doing anything in terms of monitoring and production, you just made your cluster kind of resilient against a breach. And there will be no damage, because even if I open my storefront application, you can see that the pod itself cannot even talk to the other pods. So even my storefront application is still working well, let's say, it's still working. And because it's still working, you don't have, you don't lose production. So it means you're not in a hurry to delete the attacker pod. What you can do is just isolate it and put it in quarantine. So that's another idea. With the policies board, we have the highest tier, which is security, which is the one that contains the policy that are read in the first place. And here you can have like quarantine workloads. And this one is simple. It's a policy that will block every single flow, and that will log the flow as well with the two actions, logging and denying. And it's based on labels or whatever. And what we can do here is simply label the pod attacker with the quarantine label equal true. So that's exactly how it is here. So if I go here, I can just copy paste that. Going to be a bit easier. And just get the pod name. So it's called label pod attacker. Okay, it's been labeled. And now, if I go back to my policies, the number that is 1 should be now 0, should be 1. And if I click on the endpoints, we should see my attacker pod. So it's how you can mitigate, or not really mitigate, it's more like after the incident, how you can investigate the cause of that security breach. Because if you delete the pod just to make it clean straight away and working again, you're going to lose the proof, and it's exactly what you don't want. You want to keep the trace of what happened for the security team to investigate. Sorry for the slowness. It's a bit annoying. I have time to drink now. Classic. So here is my attacker pod with the label that is quarantine equal true. And if I go back to my service graph, not the service graph, the policies, sorry. Now it's here. And we'll start to see the traffic coming in. And you can give the case to the security team for analysis. So now, imagine your security team is not really playing with Kubernetes. They don't really want to play with Kubernetes. They are not skilled for that. They just want to use their regular tools. All the flows we've seen are automatically exported to the Kibana that is provided with the solution. It's called log. So I can simply open it. And it's going to connect me into Kibana, which is an Elastic. And from there, you'll be able to request, the database and find all the events you want. On top of that, the events can also be exported or archived into a Splunk S3 syslog server. So it means your security team that doesn't like Kubernetes can still see the events without, opening Calico Cloud. Okay, that's. Okay, so what we can do is while it's loading that, we can talk to, because right now we were focused on the policy engines and network security. So we've seen that with the threat feed, we can have a protection against kind of the known threats. And with the zone-based architecture and zero trust, you can protect yourself against unknown threats when they arrive. You kind of mitigate the damages. But Calico can also provide an image assurance, image scanner. So what we can do is we have a scanner that you can install on your Mac or a Linux box. And what you do is just scanning the image and send the result to the platform. Then on the result will be seen here, exactly. And you can see if you fail or not the test. So you can use we use the CVEs to check out the images and see if you are if you're getting the score like 7, 8, 9, 10. And you can put the threshold yourself. So if you want like a 5 is a warning, a 7, 8 is a no-go. You can see that, and we have the admission controller that will avoid the DevOps to push that application because it failed the test. But that works for the known issues. What happens if there's a 0-day threat and in 1 month we know that the vulnerability exists? So we have the running images as well. So for this demo, I didn't put my attacker in that, so we don't have the result. But the idea is, let's say you have like a log4shell vulnerability running. We can see all the pods that have it. We can see like the running instances, the clusters, registries, etc. So you know exactly where this vulnerability is and on how much clusters, etc. So that's the idea for the known issues or known vulnerability for the containers. And we also have some other features like web application firewall, a WAF, and container threat detections. So the idea of the WAF, what we can do with Calico is we can enable the layer 7 monitoring, so we can see what's going on between the pods on the layer 7, so we have visibility of that. And with the WAF, we can use, the OWASP top 10, and we also have the DPI with the snort rules. It's going to look at different technique and attacks, and if something is happening, you'll get alerted. And the WAF can also prevent the connection by blocking it. And the WAF is workload centric. So it means it's within the cluster. It's not something outside your cluster, because maybe you've got like a big F5 or something outside, but it cannot see what's in the cluster. So with the WAF, you can enable the WAF for only the services you want. So in that case, I put it on my Java app. And when there will be like a technique happening, it's going to be blocked, like a 403 forbidden. And that's going to be helping your containers so to secure them. The other thing we can do is in the threat defense, we've got the container threat detections. So that's another way to detect weird behaviors into your cluster. We have eBPF probes that are going to check your syscalls, syslogs, etc. in the container. And if there is a file creation, escalation, privilege escalation, we can flag that and create an alert. And if you go in activity, you should have all those alerts visible here. So you can see a pod was detected executing a known attack tool. And then if you scroll down into that, you can have the technique, basically. What pod, what technique, what host, and so much. So here, malicious file ransomware. I was able to exploit the Java vulnerability to extract the information about the container, what Linux kernel was running the container. And I was able to adapt my payload. So it was like data exfiltration. And then I used the Java vulnerability to push a file without any credentials. And here we can see the file creation, like ransomware. So if you run the WAF, it wouldn't even happen because the WAF will block the connection on the live. But if you don't have the WAF enabled, you'll be able to still see what's going on and get the alerts. We've got something that is called anomaly detections. So it's a tech preview. They're working on it. The idea is just to get everything that is unusual. So imagine you've got like a DNS latency, DNS L7 latency, port scan. If something is unusual, It's not, it's deviating from the baseline. It's going to be flagged as well. And if you go in the service graph again, what's happening here is if you have an event that happened, you'll have a little flag, and you've got here DNS, HTTP, so the layer 7 visibility, and the alerts. If I go here, I can see there is a little flag here, and here we can see my alerts. So imagine it happens that at your job you become a Kubernetes engineer without the skills or the training yet. Maybe it's coming. You'll be able to monitor quite well your environment, and you'll be able to understand what's going on, and it will help you tremendously about Kubernetes. So with Calico, we can protect the containers from unknown threats, but also the network from known and unknown threats. And right now, I believe on the market, we are the only product that does all of that in only one product. And the thing that is very interesting with Calico Cloud is you can connect it to almost any cluster in like 5 minutes. What you can do is you go on tigera.io, you sign up for cloud, and I can just show you. You create your account, and when to connect the cluster, you just literally put the test name. You can select maybe a case. You select the version of your liking. Maybe you've got some version 16 already running and you're used of this version, whatever reason. And it creates you a script. You just copy-paste it into your shell, and the Kubernetes cluster will connect to Calico Cloud in like 5, 10, 15 minutes. It really depends. 5 minutes, 10 minutes. And then you'll start to see the service graph, the policies, the endpoints, and you'll start to play with the advanced features such as image assurance, threat defense, and so on. I think time is up. So now it's time for the questions.
Yes, Jeremy, thank you so much. Please give a warm applause to Jeremy from Calico.
Yeah, it's...
So I'm going to do like 2 questions real quick because we're already out of time. I think one question was, what does it cost? Which is like, I think, for the enterprise version, and also can the enterprise version be self-hosted?
So the cost, I think it's like a public price, something like per node or per vCPU. I don't have exactly the prices for them because not the sales, but you can just go on Calico Cloud, sign up, and then there is a button to get contacted by a salesperson.
And can you do self-hosted as well on the enterprise version if you want? Or is the enterprise version the cloud version and the open source version?
It's the price is different, of course, and you can have both versions if you want. Enterprise will be on-prem, or you can install it in cloud, but you manage the storage, you manage your Prometheus and Elastic. If you use Calico Cloud, it's self-managed. It's not self-managed, it's a SaaS, so you do nothing.
Thank you for answering the questions, and thank you for being here again at Stage K4, and I'm now going to send you off to the coffee break, and then hopefully see you again.
Thank you, everyone.